Hey guys, today we're starting our new chapter, chapter 4, and we're going to talk about graphing quadratic equations. Quadratic equations are often written in function notation, and remember, function notation usually starts off with f of x. So therefore, this is the model for a quadratic equation in function notation. It has three coefficients, a, b, and c, and it always has an x squared term. The model as a regular equation, not in function notation, is to the right, and that would just be y equals ax squared plus bx plus c. An example of a quadratic equation in function notation and not in function notation is right below. For example, f of x equals x squared plus 2x plus 1. The coefficients would be the following. For a, the coefficient would be 1. B, the coefficient would be 2, and C, the coefficient will also be 1. And to the right, we could also write the equation not in function notation. Remember, f of x could be written just as y equals. When we graph these specific equations in quadratic form or a quadratic equation, what we're going to get on the coordinate plane is called a parabola. Last section we were graphing linear equations in which we graphed a line on the coordinate plane. Here, when we're graphing a quadratic equation with an x squared term, we will be graphing what's called a parabola, and that is this U-shaped form that you see below on the coordinate plane. There are specific parts to this parabola that we're going to be talking about over the course of this chapter. The first thing is the vertex. What the vertex is the minimum or maximum point of a parabola. It is written as an ordered pair. In this case, what's on the coordinate plane, the vertex for this parabola would be that point all the way at the bottom of that U shape. That would be our vertex, and we would describe it as it's the ordered pair -2, 0. Since it's at the bottom of the parabola, we would call that the minimum point. If this parabola was upside down, we would call it the maximum point because it would be the highest point of the function. The next thing we're going to talk about, especially when graphing, is the axis of symmetry. This is a vertical line that cuts the parabola perfectly in half, so both sides are symmetrical. However, we do not graph this. So in this case, the vertical line, that would be the axis of symmetry, and cut the parabola in half would be this vertical line. As you can see, the left side and the right side are symmetrical to each other. The axis of symmetry does pass through the vertex, in which when we start graphing, it's going to be important to find the axis of symmetry in order to find the vertex, since they share an x value. And in this case, we could describe the axis of symmetry for this parabola as the equation x equals -2. That is the vertical line crossing the x-axis at -2. On the right side, we have two more terms, one being the roots. The roots for a parabola are the x-intercepts. It's where the parabola crosses the x-axis. These are also solutions to a quadratic equation when set equal to 0. In this case, there is only one x-intercept. It happens to be the vertex. That's just a coincidence there. And we would describe that root as x equals -2. In a second, we're going to discuss how a parabola could have either 1, 2, or no roots at all. The last term we're going to discuss is the y-intercept, which we should be familiar with from last chapter. That's where the parabola is going to cross the y-axis. In this case, the parabola crosses the y-axis at the value 4, so we would describe the y-intercept as y equals 4. As I quickly mentioned when I was talking about roots, there could be one solution, two solutions, or many solutions to a quadratic equation. We could find these solutions by graphing a quadratic equation and seeing how many roots it has. For example, the first graph touches the x-axis once, as does our example we just saw above. So there is one root, therefore we would have one solution. That solution would specifically be x equals 2 because that is exactly where the parabola touches the x-axis. In the second parabola, or the second graph, as you can see, it crosses the x-axis twice. Therefore, there are two roots, or there would be two solutions of the quadratic equation when set equal to 0. In this case, we would say that the two solutions, or the two roots, would be -3 and 1, since that is exactly where the parabola crosses the x-axis at those values. And lastly, a parabola could have no roots or no solutions, looking at the third graph. This is when the parabola does not touch the x-axis at all. On this second page, we're going to identify parts of the parabolas that we just discussed. We're going to talk about the vertex and whether it's a minimum or maximum point, the axis of symmetry, the x-intercepts, and the y-intercept. I am going to go straight down the first column, and I'm going to leave the second column for you to practice on your own. For the first problem, the vertex, again, is written as an ordered pair, and that would be this green point on the parabola. That ordered pair would be -3, -3. Since it's on the bottom of the parabola, it's the lowest point, we would describe this as a minimum point. The axis of symmetry is that dotted red line, vertical line that cuts the parabola in half. When we go to graph these quadratic equations on the next page, we don't have to graph that axis of symmetry, but you're going to see that it is going to be important to find it in order to graph the parabola. We're going to write the equation of that vertical line, which would be x equals -3. There are two x-intercepts, or two roots in this case. We would write it as x equals, and this is going to be written as a solution set because remember, these are solutions to an equation when set equal to 0. These two x-intercepts cross the x-axis at -5 and -1. And lastly, there is one y-intercept. That's where it crosses the y-axis. It's that orange point on the graph there. And in this case, we would say y equals, and it crosses the y-axis at 3. Let's take a look at the graph below here. This graph is concave down, as the first graph is concave up. When it's concave up, it's facing up like a U shape, and when it's concave down, it's facing down like an N. So as you can see, our vertex is now at the top of the parabola. We would write that as an ordered pair -2, 3. And since it's at the top of the parabola, since it's concave down, that would be the maximum point of the function. The axis of symmetry, again, is that vertical line cutting the parabola in half, which is x equals -2 in this case. That is the equation of that vertical line. There are, again, two x-intercepts. We write that in a solution set because, remember, these x-intercepts, or roots, are solutions to a quadratic equation when it's set equal to 0. And in this case, the x-intercepts, or the solutions, would be -4 and 0. And lastly, there is one y-intercept. It happens to also be a root. This parabola crosses the y-axis at 0. Let's go ahead and do one more together. The second problem we did was concave down, shaped like an N. The third problem is concave up. It's shaped like a U. The vertex is at the bottom of this U shape, or the bottom of the parabola, and is written as an ordered pair. In this case, it would be 2, 1. Since it's at the bottom of the parabola, we're going to say it is the minimum point of the function. The axis of symmetry is the vertical line, and the equation of that vertical line is x equals 2 because it crosses the x-axis at 2. There happens to be no x-intercepts or no roots here, so I would do the empty set notation, showing that there are none. There is one y-intercept. In this case, it is that orange point on the y-axis here, in which we'll say that that would be y equals 4. What I'm going to do is ask you guys to pause the video and try the 3 to the right, the second column. Once you get your answers, go ahead and play the video to check. Here are your answers to the second page, the column on the right-hand side, identifying the specific parts of those parabolas. Remember, in the first problem on the right, this is a concave down shape. It's facing down like an N. Therefore, the vertex would be at the top of the parabola, which would be a maximum point. And the second one is facing up like a U shape, in which the vertex is at the bottom of the parabola, and it is our minimum point. Now that we discussed all the parts of a parabola, we're going to now go ahead and graph quadratic equations in which we will get this parabola shape on the coordinate plane. In order to first learn the steps of graphing a quadratic equation, we have these just models and tables here to bring you to each specific step in order to graph a quadratic equation. We're going to do this first one above. We want to graph the quadratic equation. This is in function notation. F of x equals x squared minus 8x plus 12. The first thing you're going to want to do is identify the a, b, and c values. Remember, from the first page, a quadratic equation is in the form f of x equals ax squared plus bx plus c, where a, b, and c are our coefficients. So in this case, what's our a coefficient? That would be 1, since there's no number in front of the x squared term. The b coefficient is negative 8, and c would be 12. We also want to identify whether this quadratic equation is going to tell us whether the parabola is going to be facing up like a U or down like an N. How do we determine that? That's all with the a value. That's going to tell us whether it's going to be facing up or down. And if the a value is positive, as it is in this case, the parabola will be facing up like a U. I could quickly just give you a sketch. And since it's facing up like a U, will the vertex be a minimum or maximum point? Well, if it's facing up, the vertex would be at the bottom of the parabola. Therefore, it would be a minimum point. This is really just collecting some data so that we could continue to graph our quadratic equation. The next step you're going to want to do is find our axis of symmetry. Remember how the axis of symmetry passes through the vertex? Therefore, it's very important to first find this axis of symmetry, the vertical line that cuts the parabola in half, because it's going to then help us find the vertex in the next step. The way we find the axis of symmetry is by using this little formula, x equals negative b over 2a. Remember, since it's a vertical line, the equation is going to be x equals and then a number. We're going to find that by plugging our values in. We have x equals, b in this case is negative 8. So we have negative 8 because the formula is negative b, divided by 2 times a, which in this case is 2 times 1. We're going to go ahead and simplify. Negative 8 is positive 8, divided by 2 times 1 is 2. And finally, we get our equation of our axis of symmetry, x equals 4. Again, this is now going to help us go to our next step, which is finding our vertex. The axis of symmetry passes through the vertex, or the ordered pair. Therefore, it's going to share an x value. So we already know the x value of this ordered pair, or the vertex, given the axis of symmetry. We're now going to use that to find the y value. As you can see in this step, it says plug in x value to find the y value. I'm going to go ahead and just copy down our function f of x equals x squared minus 8x plus 12. This is in function notation. Remember, we could write this as a regular equation with y instead of f of x, in which sometimes it helps some students find now the y value now that we have y. Since we know x is 4, I'm going to go ahead and plug it in to solve for y. So we'll have 4 squared minus 8 times 4 plus 12. Please be very careful with your work. We're going to use the order of operations, in which we will first use the exponent. 4 squared is going to give us 16. Minus, we'll do the multiplication. Negative 8 times 4 is negative 32 plus 12. Next step would be the subtraction first. 16 minus 32 is negative 16 plus 12, and we'll finally arrive at our y value, which is negative 4. Now that I know the y value, I now know the ordered pair of my vertex is the ordered pair for negative 4. Now that I know the vertex, which is the point essentially in the center of the parabola, either the maximum or minimum point, what I'm going to do is use that vertex to now make a table of values. Since the vertex is in the center of the parabola, we're going to put the vertex in the center of our table, in which will now help us find the left and the right side of that U shape. We're going to go ahead and pick our x values in order from the vertex. So since the x value vertex is 4, we'll now pick 5 and 6, and then we'll go backwards and pick 3 and 2. How are we now going to find the y values? Well, just like we found the y value for the vertex, we will be plugging these x values into our function to find the y values. For example, I'm going to again write down our function. Y equals x squared minus 8x plus 12. And I'm going to substitute each x value into our equation to find the y value. The first one I'm going to do is 2 to get 2 squared minus 8 times 2 plus 12. We'll end up with 4 minus 16 plus 12, or negative 12 plus 12 to get us y equals 0. Since I know y equals 0 when x is 2, I will then enter it in our chart. What I'm going to ask you guys to do is pause the video and plug in the x values 3, 5, and 6 in order to get the y values, and once you get your answers, go ahead and play the video. When plugging in each of the x values, we should get the following y values, and now which we could use to graph on our coordinate plane. Since we are graphing a quadratic equation, what we should get is that U shape. And if we go back to that first step, we know that it's going to be facing up like a U with the vertex at the bottom. So what I'm going to do is make my x and y axis. Make sure you put your x-axis high enough so that we could fit all of our points, because as you could see, we need to graph for negative 4. So I'm now going to plot each of the points that we found. First one being 2, 0. Next one, 3, negative 3. Next one, 4, negative 4. 5, negative 3. And 6, 0. Notice the vertex for negative 4 that we found before is in fact the vertex of the parabola, and it is the minimum point. I'm going to go ahead and trace these points. This is not a V shape, it's a U shape. So try and make it as smooth as you can on the bottom. And now that we have our parabola, we can label our roots. Since it crosses the x-axis twice, I know I have two roots, one being 2 and the other being 6. What I'm going to ask you guys to do is pause the video and go ahead and follow the steps in graphing our second function. Once you get to the end, play the video to double check. Alright, so here's your answer for the second quadratic equation. Our values for A, B, and C are 1, 8, and 16. Again, just like the first problem, it's going to be facing up because the A value is positive. And since it's going to be facing up like a U shape, the vertex will be at the bottom, so it would be a minimum point. The next step is finding the axis of symmetry using our formula here, negative b over 2a, in which we would end up with x is negative 4. Since the axis of symmetry passes through the vertex, we are then going to use it to find that ordered pair. The x value of the vertex is going to be the same thing as the axis of symmetry, which is negative 4. And we're going to go ahead and plug negative 4 into our function to then find the y value, which happens to be 0. Moving on to the table of values, the vertex is the center of our parabola, so we're going to put it in the center of our table of values. We're going to then follow the x values by counting back, so negative 4, negative 5, negative 6, and then negative 3 and negative 2. We'll then plug those x values into our function to find the y values you see in their table. Please make sure you're using the order of operations and you solve it very carefully to find those y values. Notice in both of the problems, we did have a sort of pattern here in which the two values next to the vertex would be the same, and then the first and the last values 2 away from the vertex are the same. You could see that pattern in both of our table of values, which will continue going forward. That's not a coincidence. Since it's a U shape, if you go out the same amount of values or units, you're going to go up or down the same amount of values since it's a symmetrical shape. Once you then plot all your ordered pairs you found in your table, you could double check to see that your vertex is in fact negative 4, 0, which you did find a couple steps ago. And since it crosses the x-axis once, we have one root, which is x equals negative 4. In these first two examples, we have parabolas facing up like a U shape. In the next two examples, we're going to find two parabolas that are facing down like an N. So our next problem here, as you could see, is missing a term. Remember, the model for a quadratic equation is f of x equals ax squared plus bx plus c. Let's look into which value is missing in this case. A would be negative 1 because the a coefficient is the number for the x squared term, or the coefficient for the x squared term. Since there's a negative on the outside, that would represent negative 1. B is the coefficient for the term with x to the first, or just x in it. Since that term is not there, that must mean that b is 0, and c would be negative 3. Since a is negative, this parabola is going to be facing down like an N shape, which would put the vertex at the top, and it would represent a maximum point. Let's go ahead and find our axis of symmetry using our formula. Since we have x equals negative b and b is 0, we have 0 divided by 2 times a, which is negative 1. And we know 0 divided by anything is 0. Therefore, the vertical line that will cut the parabola in half is the line x equals 0. It is actually right on top of the y-axis. Since the axis of symmetry does pass through the vertex, they're going to share an x value. The vertex is written as an ordered pair, in which we now know the x value of that ordered pair is 0. Let's go ahead and plug that in to find our y value. I'm again going to just copy our function which happens to be in function notation here. We, of course, can rewrite it with y as y equals negative x squared minus 3. I'm going to substitute 0 in for x to figure out what the y value is when x is 0. And when we simplify, you have to do the exponents first. We're going to use the order of operations. 0 squared is 0. And then we'll be left with negative 0 minus 3. Since negative 0 is 0, we have 0 minus 3, and we could find out that y is negative 3. Our vertex is the ordered pair 0, negative 3. Since it's in the center of our parabola, when we're making a table of values, we're going to put it in the center of that table of values and follow with the x values accordingly. So if I start with 0, I'll then use 1 and 2, and then let's use values less than 0, like negative 1 and negative 2. We're now going to plug these x values into our function to figure out what the y values are. So our function again is f of x equals negative x squared minus 3, or y equals negative x squared minus 3. Let's go ahead and plug negative 2 in first. Y equals negative 2 squared minus 3. Notice how I'm putting parentheses around the value that I'm substituting in. Again, just like before, we have to do the exponents first, order of operations, to get negative 2 squared, which is positive 4. So we'll be left with negative 4 minus 3. And negative 4 minus 3 is going to give us negative 7. Here are your y values for our table of values. And notice, just like the previous problems, the two y values next to the vertex would be the same, and the two y values 2 units away from the vertex will also be the same. You could use this as a little trick to go through the table a little bit quicker, but what I would rather recommend you do is to use it as a check to make sure that the y values are correct. Let's go ahead and plot the ordered pairs that we found. First one being negative 2, negative 7. The next, negative 1, negative 4. 0, negative 3. 1, negative 4. And 2, negative 7. Notice the ordered pair 0, negative 3 is in fact our vertex, which we found before. We're going to go ahead and trace the points as best we can. This parabola will go on forever to negative infinity, which is why we put the arrows on the end. And in this case, since it does not cross the x-axis at all, there are no roots, and we could put the empty set symbol to represent that. Here is our answer for the last quadratic equation. Again, since it's a negative a value, it's going to be facing down like an n. We're going to go ahead and find the axis of symmetry. If b is 6, then negative b would be negative 6. Divided by 2 times negative 1 is going to give us the vertical line of x equals 3. Since the axis of symmetry passes the vertex, the x value will also be 3, and we're going to go ahead and plug it in to find the y value. This is usually where common mistakes come in. Make sure you're using the order of operations, and when you're simplifying or evaluating for the y value, make sure you're using the exponent first and then multiply by the negative on the outside. So we're going to get negative 9 plus 18 minus 4, which will give us the y value of 5. Once we find our vertex, we could go ahead and make a table of values and choosing our x values to follow. We're going to plug those x values into the y values, and just like when finding the vertex, just be careful with that negative x squared term. The exponent is first and then multiply by negative 1. And once we plot all of our points, again, our parabola is going to be facing down like an N. The vertex we found at 3, 5 is in fact the vertex of our graph. There are 2 roots, however, we can't necessarily identify exactly what values they are, so we could just identify that one of them is between 0 and 1, and one of the roots is in between 5 and 6. If you have